Hi there everybody. So I'm going to tell you guys in this video all about making 3D flowers or atomic flowers. Okay, there's a few elements that go into creating an atomic flower. The first one is going to be your hand path. Like the hand paths are the most fundamental, like building block, I guess. And the hand paths are going to be dictated by the orientation of the atom to you, and also the timing of the orbit of each poi head through the atomic shape. Okay, and then the last element of the 3D flowers is going to be your driving style, whether it's like in spin or if it's anti-spin or if it's just an extension. You know, that's going to be, it's going to determine a lot about them, because then you get any of those can be hybridized together. So there's lots of options. So to get back to just kind of the basic idea of what is a 3D atom and how would you make it into a flower. So let's look first at just an atom. You have two planes that are perpendicular to each other, and they share an axis right there in the middle, and that is the pole of the atom, like North Pole, South Pole of the Earth. This is the pole of the atom right here in the middle. And you can see that the poi, as they pass the ends of that pole, are split, one on one side, one on the other. That's a lot like this, right? If there's a pole right here, one on one side, one on the other. So that's split time. If they're both passing one side of the pole, that'd be same time. Example of that atomically would be boom. And if one is 1/4 of the way behind the other while passing the pole, then that would be quarter time. And with an atom, it would look like that. Pole, 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 pole. So, Lork has a very great video on hand paths of these different atoms. And so he calls together time tog L. And because when you get your hands together, then they're in an L shape, then they're together, then they're in an L shape, and then together. And you might notice that the pole in that atom that I just demonstrated was up and down. Now watch, if the pole was towards you, my hands would be together, and they would be L shape, then together, and then they'd be L shape, bam. So it's together time along this pole. So that's kind of, so that's together time. And then split time would be hands split along the pole, and then an L shape, and then split along the pole, L shape, split, like that. And so that'd be split time, or he calls that split L. And then there would be quarter time, which would be, 1/4, 1/4, 1/4, 1/4. And if you notice, this is an L shape, now this is an L shape, now this is an L shape. So he calls that one infinite L. Quarter time equals infinite L. So those are the hand paths. I'll just go through them again for you. These are all the hand paths for a crosshair atom like this. Okay, so we have together, then we have quarter, and then we have split. So those are all the hand paths for this one. This is a crosshair atom. The hand paths are basically the same thing for the vertical versus vertical. They'll be together, and then infinite L. Oh my goodness. That. I don't do that one very often. And then split. Like that. Now, if you know about plane breaking and that sort of thing, anti-spin will be the easiest driving style for you to move. Okay, I just kind of jumped ahead real quick, but plane breaking will really help with all this. That's kind of where my mind was going with that insertion there. So the next thing that we want to look at, that's just two orientations. There's also this orientation, which is the tilted atom. So that'd be this one. And we'll talk about that one last, because it gets kind of funky. And just as a note, I also want to tell you guys about this one, vertical versus diagonal. This is another kind of atom. Really, the only time you're going to run into that is when you're doing plane breaks in the box mode. Then you can access that atom pretty well. It's a weird one. I don't use it a lot, but it's there, and it's a cool thing just to throw in. Boom. I've never really experimented with making flowers or add them, so if you're interested, go ahead and mess with that yourself, but I can't really get any tips as of right now. Okay, so the next thing would be driving style, right? So we have our hand paths down. Let's just start with vertical versus vertical because in my opinion, that's the easiest one. Now, the driving style would be whether it's like in spin, anti-spin, or extension. Those are like the easy basic ones. There may be more, there may not, I'm not sure. But all of the ways that you can combine those things. So you could do like, this would be 4-petal, let's say. It's kind of cool right here because we have an atom, petals, and we have an atom, petals, atom, oops, atom, petals, atom, petals. So that's a 4-petal in-spin flower. If we move our hands the other way, it feels a little more like plane breaking. We got like this. So that's a 4-petal anti-spin. And then you could just do your extension. Or you could do like extension versus anti-spin. And then these are like hybrids. And we'll keep hybrids in mind because they can become important for these tilted ones. So the same thing goes for crosshair atoms, right? So this would be like 4-petal in spin, and then 4-petal anti-spin. See, now, one thing, this is a split time atom, but I really like the feel of kind of starting with one, and so it kind of turns into quarter time, and you just kind of have to end the one there. You could do like these, feel a lot easier to keep clean the same time, together L, for the 4-petal anti-spin, but I really like the kind of like follow effect, and I don't know if you noticed there, I was going to go into hybrid. Okay, so let's just jump into hybrids right now because they, in my opinion, are the most satisfying to do. They feel the most natural, and I think it's because of the intersection point of where the atom is. But if you, so here, I'll show you from the side. This is one of my favorite ones. You got the horizontal one's going to anti-spin, and this one's going to do a 2-petal in-spin, so it'll just scoop, and then see how that just pops right back into that atom. Now, so if you don't want to do a 360, you can just extend and then extend back, and that's kind of a cool pattern there. But you can do the 360 too, and that one feels really nice. I love those. The other reason that hybrids are important is for this guy, and this is just if you take a buzzsaw and you tilt the tops out and then put your hands together, you end up with this tilted atom where they both kind of feel like they're moving forward. You take that same move that we just did and you go scoop out with the blue one. It's kind of diagonal scoop out. And a weird thing happens. You'll notice the tilt seems to change when you get to the other side. So now it's like the triangle side is pointing up. You just have to mess with it and see what I mean. But that one does the 2-petal in spin, and then this one makes that 4-petal anti-spin move. It feels super strange because here it's tilted the other way and goes down. It takes some messing around with, but I really like using it. You know, it looks kind of neat. And it feels hella ninja. And you can do the same kind of head tracers and stuff with these tilted ones. But that's a lot to mess with. That's a lot to play with and explore. But I hope that's given you the foundations, kind of the frameworks for how to go about exploring these. So, Merry Christmas, and I'll see you guys all soon.